Go. All right. My name is Garrett, and my partner is Zinan, and we did our project for regression analysis on three independent variables, testing one dependent variable of the average rating, or sorry, the weekly sales rank of the tablets. So quick overview of what we did was first we looked at how the data was collected, and we saw that it was done through an automated web scraping. This was done using a Java crawler that collected weekly market dynamics, and these included sales rank and various other aspects. And it also did consumer reviews with the Amazon tablet category from February 1st to July 11th of 2012. And then it collected data based or through a manual compilation. So there was product specifications such as RAM, screen size, and these were manually gathered from the manufacturer's websites. And the data types were also collected. So the data set includes both structured data and unstructured data, such as customer reviews. So some concerns and limitations that pertain to this data collection are one, selection bias, because there was only Amazon data used, so it's missing other large retailers such as Walmart or Best Buy, since we're doing technology. And it also only includes products with at least one review. So this is probably a good thing, but it could overlook products that are in a smaller niche category. And then another limitation is potential web scraping issues, meaning that there's potential for incomplete data or if their website changes. And then the data might also be outdated if Amazon's listings weren't collected at the current collection date. Another risk is the manual data entry, because obviously humans often make errors when doing very mundane tasks. And then another limitation was the time constraint. This was done over a 24-week period, which, when looking at a data set this large, it's often better to do this over a longer period of time, possibly a year. So this may not catch the long-term trends such as seasonality. And then another limitation was the review quality. This could be that user reviews could include fake or biased content, which could potentially skew reviews and ratings of a product in either direction. So the research question that we focused on was what drives a tablet's weekly sales rank on Amazon. And to test this, we used three independent variables, which included average rating, previous week's list price, and previous week's lowest used price. And we were testing this against the dependent variable of weekly sales rank. And when we chose the previous week's list price and lowest used price because we needed to rule out any simultaneous causality, which would have occurred if we had used just the current week's list price and current week lowest used price. So to give some more background on why these independent variables, we chose average rating because this is generally positive, but research suggests that ratings near a perfect score around 4.7 to 5 may not correlate with the highest sales. So we wanted to test the strength of the relationship here. And then looking at the list price, Amazon suggests that rank is based on sales and sales volume, and it's not the list price directly. So we wanted to test if list price actually shows any direct influence on this data set. And then the lowest use price. Studies show that price drops can improve rank, but the effects vary. And so we wanted to explore this dynamic for the tablet specifically. So some limitations for this data are uh, the sales rank interpretation. Rank changes aren't linear with sales jumps, and this means that a jump from number two to the number one product is less likely than going from the 500th product in a category to the 501st because there are less reviews and it's often easier to make bigger jumps when you have less volume of reviews. And then review authenticity was another limitation. We aren't able to verify if the reviews are genuine. Again, the short time frame is another limitation of this, and missing out of stock data. We can't account for time products or times products were unavailable, which hurts sales and ranks, meaning if a product is out of stock, then there will not be any sales. So then without any sales, there won't be any reviews. And finally, the scope of this, we used a subset of the data, not the entire data set, and we focused on records with complete information for our key independent variables after cleaning. And the rationale behind this was to allow for focused analysis on review impact and remove noise from any incomplete error entries that gave an NA error. And some other variables that we used are the lowest new price to control for the general price effects and motion and promotions. We chose number of reviews as well because the influence of review volume gives quote social proof in psychological terms. And we also accounted for brand loyalty as well as product features such as screen size, operating system, battery, RAM, because products are often more desirable when they have more features. And in terms of handling the missing data, we did find that there was some missing data, so we did drop the rows of observations that had missing values. This was found when we were looking at the price, so we had to drop some rows that didn't have a price included for the product. And we did this to ensure that the model runs on a complete data set, aiming for a better fit and more reliable results. And then Xenon can take us
Sure.
through the results.
All right. So, yeah, based on like what you said before, I'm going to show like which model is the best fit here, and also for like among all the variables Garrett just mentioned, I'm going to talk about which ones we included and why we include that. So. Firstly, we subtracted, sorry, like we extracted this train data from the whole data set. And this is like 20% of the total data set to use that to test the models we constructed as a step. And I tested for several models here, including like the sales rank to like average rating, review volume, verified proportion, screen size, and the average like the battery age. So among all these models, the like the best fit one is here. That is the relate like the dependent variable is the log of sales ranking, and the independent variables they're the log of average rating, review volume, verified proportion, log of the screen size, and the average battery age. So why I choose this model is that we can see according to the like the R square here, yeah, the value of the R square. Um, the model we choose here has the highest R square. So it's the best fit among the five models we tested. Yeah, and so the conclusion we can reach here is for all these five, sorry. Oh wait, and also like this is just a training model. When we use the test model, like the test data set, which is the rest of the 80% data, we can show that, yeah, we can show that the result still aligns with our finding. The test model here, it has the R square of point 16. Well, for the rest, this is much lower, and like the highest would be only point 15. So according to the two tests, both the training data set and the test data set, we can conclude that the model we selected here is the best fit. Yeah, so it's something based on the R square, and the findings here we would like to conclude is for all the variables we included before, the average rating, review volume, verified proportion, log of the screen size, and average beta life would be would pose a significant impact to the sales rank. Yeah. And also, I'm going to talk about like how significantly these variables gonna affect the final results. So, we can see like I conducted some t-test here, and based on the summary, we can just use the t-values here. So first of all, I calculated the threshold z-score, which is um, yeah, which is negative 2.306. And I just take the absolute value here and also use the absolute value of all the V values here to see whether it's in the rejection region. So as we can see, the absolute value of all these T values, they're like they exceed the threshold. So we reject the null hypothesis here, which is like the which is like the average rating, review volume, verified proportion, like all these variables, they have no significant impact on the average ranking. So the alternative hypothesis, which shows that for all these variables, they will have a significant impact on the sales ranking. So this is somehow different from the current evidence, because according to the consensus in the market and some of the research we conducted, the current evidence shows that the average battery life and the log of the screen size, they usually do not significantly impact the sales of those computer or touchpad tablets. But according to the results here, especially like the t-value, we could conclude these are also very significant factors for the total sales ranking. Yeah, so and for the rest of the variables, like the log of the average rating, review volume, and verify the proportion, they just align with the consensus in the market. So these three are the similarities between the current evidence and our findings. But for but there's some difference between like the current finding and the evidence in the log of screen size and average battery life. Yeah, so these are our conclusions. And I just restate. Um, so for all the average rating, review volume, verified proportion, screen size, and the battery life, they have a significant impact on the average ranking. And among all these factors, the average rating has the most significant one, because the beta here is the largest, as we can tell from the coefficient here. Yeah, so that's our conclusion. Also, we showed why it is significant and what's the difference and similarities between the alternative hypothesis here and the current evidence we have in the market. Yeah, so that's our results, the analysis, and the conclusions.